OOP, there are some, do I call them? Okay, there are characteristics of object-oriented programming. Yes, or paradigms, as you might want to call them. So under OOP, we have one, we have encapsulation, we have abstraction, we have polymorphism, and we have inheritance. So this terminology, let me just explain them. So in encapsulation is such that we want to hide like the entities that work on the class. Like let's say you have a class, everything that works in that class, the behavior, everything, we want to keep it private to that class, to that entity, so that it cannot be interfered by external parties. I'm sure that you've seen some drugs that you don't see the contents, you just see them inside a capsule. We call them capsules, like, but the contents, the thing that actually cures the ailment is inside that capsule. The content is inside. So that external, let's say you bring it out so that it does not get infected or affected by the external, yes, let me just like that. So that's encapsulation. So you are keeping the thing that you are the data, and then where it works on, things that the data works on, they are kept together, they are compacted within that class, so within that entity, so that it cannot be manipulated by external parties. That's for the encapsulation. Then we have inheritance. So inheritance is such that like when you say inheritance in normal day-to-day activities, your normal day-to-day terminologies, when you say inheritance, you are inheriting, or you are getting specific traits or features from someone else. Let's say a child inherits from the parents. You inherit from your parents some certain features. So in OOP, there's a terminology for inheritance, where you're able to like get special. It's possible for you to get inherit special some qualities, some behaviors from another class, from another entity. So that's inheritance. Then we have abstraction. Abstraction is such that we want to keep the thing we want to keep the logic, the complexity of that class or that entity. We want to keep it private and just show the user the place that is easy. For example, many people can drive cars. Yes, but then it's not everybody that knows how the engine connects together for the car to move. All they just know to do is to match the brake at the right time, match the clutch at the right time. They just know what to match at the right time. It's just easy. You just know, okay, match this, move the steering like this or like that. But then as you are doing all that, there are many complex activities that are going behind the scene that you don't see. That's what we refer to as abstraction. So those complexities, they are hidden from the user. So we just show the user the part where they can use to interact with that system. We don't show them the complexities. We just show them the easy parts where they can just use to work with that system. Then also we have dimension again, polymorphism. So this is where a class or an entity can exist in several forms. All of these are attributes of OOP. So it's when we actually dive into all of these that we are able to go in depth each of them. So why these theories? So why these theories? So I'm trying to explain this theory so that you understand, okay, this backend, this is not abstract. There's actually a real life situation they're trying to model. So trying to model a real life situation. Then when we've gotten the idea,